Hi everyone, this is the second part of the video lesson for 4.2 critical points, local maxima and local minima. So in the first video, we move all the way to example 1c. If you haven't watched the previous video, make sure you watch it first before you continue with part 2. So I hope you've tried 1c, f of x equals to x to the power 3 minus 2x squared minus 4x. Here's the first step. Find the derivative. F prime equals to 3x squared minus 4x minus 4. Step 2, you set this to 0. Step 3, your goal is solve for x. By inspection, you can tell that there are two answers, and from grade 10 academic math, you did complex factoring. So if you think about 3x squared, that's going to be 3x times x. If you think about the factors of negative 4, that would give you a sum of negative 4. One combination, or maybe I should say the only combination, is negative 6 plus 2. So now, when you solve for x equals to negative 2 over 3, or x equals to 2. Again, really important you form the habit of finding the critical points, not just the x values. So in the first case, x equals to negative 2 over 3. In the second case, x equals to 2. You can take your calculator and plug it back in to x cubed minus 2x squared minus 4x. And if you do this twice, it would give you the two corresponding y values. Now, in the first case, when x is negative 2 over 3 and you work it out, this will equal to 40 over 27. Likewise, it will be negative 8 when x is 2. You can press pause to confirm this and press play before you keep going. And of course, if my answers are incorrect, you can comment below. I'll be happy to respond accordingly. Now, one thing you notice is when you graph this, right? Not that we have to graph it, but you want to at least have that mindset. It's very difficult to graph negative 2 over 3 or 40 over 27. So what you can do is write down the approximation for the first critical point. So negative 2 over 3 is approximately 0.7, negative 0.7, and 40 over 27 is approximately 1.5. And we'll finally confirm this at the end when I graph it with you. Again, you form the table. There are two different columns. The first column is going to be IOI, interval of increase. The second column is going to be IOD, the interval of decrease. So in the first case, you know that the derivative must be positive. And in the second case, you know that the derivative must be negative. Now, this skill you have learned from MHF. So I'm going to go back to the top for a moment and kind of show you the fastest way. Because if you think about this, you can draw a number line. You have these anchor points, and the anchor points include negative 2 over 3, positive 2. Now, from MHF, notice how this is positive, odd, right? The function, sorry, I'm looking at the wrong function. From MHF, notice how f prime is positive even. Positive even. So this means when you want to find out when 3x plus 2 times x minus 2 is positive or negative, we'll show you both cases, you know it's going to be positive even, which means the AND behaviors is going to be from quadrant 2 to quadrant 1. Notice how the exponents are odd, so it's going to cut and it's going to look something like that. Notice I put circles around the anchor points, which is independent of the answers. So you can tell, if you go back to the table now, that it will be increasing at these intervals and it will be decreasing in between. So if I write this down, this means the interval of increase occurs when, and there are two ways of writing this, when x is less than negative 2 over 3, or when x is greater than 2. Now, the second expression is you can express it in terms of interval notation when it's in between negative infinity and negative 2 over 3, union, which means or, between 2 and positive infinity. Likewise, for the interval of decrease, this occurs when x is in between negative 2 over 3 and 2, or if you want to express this in interval notation, you could write between negative 2 over 3 and 2, just like that. Now, what does that really mean? Again, if you look at the big picture, right? First, the function is increasing, then it's decreasing. This means this point must be a maximum. And again, we know the maximum occurs at negative 2 over 3 and 40 over 27. Likewise, if you look at the second part, the function is decreasing, then it continues to increase. So this must be a minimum. And again, the exact location is going to be 2, negative 8. So that's kind of the first derivative test. Again, there are 4 cases which I explained already from the first part, and I'll summarize this again at the end. Now, this is the most important part, the bonus step. If you want to confirm you're doing it right, what you can do is you can graph this to double check your work. So, if you use decimals, for example, you can go back and graph this to see if everything lines up with the answer that you've calculated. So if I enter x to the power 3 minus 2x squared minus 4x, here's the maximum and minimum respectively. So I hope you can see the maximum is located at negative 0.7, 1.5, same answer as our work, and the minimum is 2, negative 8. And again, the function increases, hits the maximum, decreases, hits the minimum, and continues to increase. So this is how you know everything makes sense. Let's keep going. Now, page 2. In example 2, we're looking at number 12 on page 179. Let's try this. Again, you can do it. You can do it. You can do it. Now, if I look at this, this is page 179, number 12. For f of x equal to x cubed minus kx, where k is an element of real numbers, find the values of k such that f has a, no critical points, b, 1 critical point, and c, 2 critical points. Again, before I start, I do want to just reactivate some of these skills that you have learned from grade 10 academic math. So from grade 10, I'm really hoping you remember, from grade 10, if you use the discriminant, which is b squared minus 4ac, there are 3 cases. In the first case, if this is positive, this implies there are 2 real roots. In the second case, if the discriminant equals to 0, there are 2 identical roots, also known as 1 real root. And of course, in the final case, when the discriminant is negative, there are 2 complex roots, by the way, or no real roots. You can say no real roots, or maybe I'm going to erase this and say 0 real roots, just to keep it consistent. That's it. You can do this now. If I go back to the question here, step 1, I'm going to copy it. F of x equals to x cubed minus k times x. So my first step is to find the derivative. So f prime equals to 3x squared minus k. Now, just in case, right, you really forgot grade 10, right? What you can do is rewrite this with an empty parameter. So 3x squared minus k. Notice the space in between because I'm adding the empty parameter 0x. And the reason I'm doing this is because I want to make sure that everybody can see this. Nobody should be left behind. A, B, and C are 3, 0, and negative k respectively. Now we can do parts A, B, and C. In the first part, they're asking no critical numbers. So no critical numbers is parallel to saying no real roots. So that's when you think about the discriminant b squared minus 4ac to be negative. So in this context, it's going to be 0 squared minus 4 times 3 times negative k to be negative. And of course, if you do this, negative 4 times 3 times negative 1, that's 12. 12k is negative, k must be negative. Likewise, in part B, b squared minus 4ac equals to 0 because they're asking one critical number. So one critical number is parallel to one real root. Again, in this context, it will be 0 squared minus 4 times 3 times negative k. When you work this out, 12k becomes 0, k equals to 0. In part C, once you recognize the pattern as expected, b squared minus 4ac will be positive this time because they're asking for two critical numbers. And again, in this case, this is going to be 0 squared minus 4 times 3 times negative k greater than 0. 12k is going to be positive, which implies k must be positive, just like that. So let's put some check marks. This is kind of who I imagine you would become on the next assessment. You can do this.